So this is a quick overview of the source code for the motion sensor project. Let's go ahead. So we're looking at our GitHub repository right now. Let's go ahead and jump into the src directory to look at the source. So like the slides before said, we have alarmdevice.py, client.py, and then inside of classes we have network.py. Alarmdevice.py is going to be running on the Pi, client.py is going to be running on whatever external device you want to communicate with the Pi, and alarm device is going to use the network class to kind of abstract the socket code to make it a little bit more usable. So let's go ahead and start in alarm device. So if we take a look in here, you'll see that we have a few imports up top. So from the GPIO0 library, we're importing the motion sensor and buzzer modules. Then from our network class that we wrote, we're importing network so that we can instantiate objects. Then we're importing time so that down here we can use time.sleep. Cool, so let's go ahead and run through this code a little and take a look at it. So the first thing we're going to do here is the network setup. So because we wrote the network class, that's as simple as saying server equals the network constructor with the port we want the socket to be open on. And then server is now our socket object, or network object, but underneath there's a socket object in there. So the next thing we're going to do is the buzzer setup. Pretty similar, so bz equals buzzer constructor. 17 is the pin the buzzer is going to be operating on. Next thing down here is the motion sensor setup, so ms equals motion sensor constructor with pin 7 as the data pin. The next little section here, lines 15 through 19, is just something to allow the motion sensor to acclimate to its current environment. So the way it's working, it's going to the motion sensor is implemented using the smooth buffer class from the GPIO0 library, which means that it needs a certain amount of data to have a reliable output. So what it does is it collects data on a continual basis, adds it to a buffer, and then the actual output you're seeing is going to be an average of the buffer. So that's what we're allowing it to do here. Just give it a bit of time. So once it's done warming up, we're going to go into this try catch loop. So it's going to do this while loop, and it's going to be able to be interrupted by Control C and kind of close gracefully without just cutting off the server connection. So inside of this try block here, you can see we have a while true loop, so it's just going to execute continuously. So each time the loop executes, it's going to check if the motion sensor has detected anything. So ms.motion detected is a function that returns true if the motion sensor has detected motion, false otherwise. So if motion is detected, we're going to go ahead and print motion detected on the Pi itself, which is useful mostly for debugging purposes. The next thing we're going to do is alert the server that motion was detected. So this is just a server method we'll kind of look at more in depth in a sec. We give it a string, that is the message we want it to send. Then we're going to turn the buzzer on, let the buzzer go for 5 seconds, and turn the buzzer off. Then once this is all executed, it's going to go back up to the top of the while loop and check again if the motion sensor is detecting motion. Cool, so that's about it for this file. Let's go ahead and jump into the client.py file. So this is just a simple Python program that's going to run on whatever external device you want to receive messages from the Pi. So the first thing we do is import socket so that we can establish the connection. So we create the socket object here, define the port 12345 like we said it was in alarm device. And then we're actually going to attempt to connect. So s.connect, and then we're going to give it a tuple with the address of the Pi and the port that the Pi should be listening on. And then in here, it's just a simple while true loop that's going to look for messages from the Pi. If there is a new message, it's going to receive it, it's going to decode it, and it's going to print it. and then just go back up and do the same thing. Cool, so let's go into our classes now and take a look at network.py. So if we look at this class, it's pretty simple, about 21 lines. So the only import we have here is socket, and then you can see we have the constructor and then two member functions. So let's take a look at this. So the first thing we're doing in the constructor is assigning the port to a data member of this object, and then we're creating a socket object. So socket was created successfully, and then we're going to bind that socket object to we're going to give it a tuple here, and this tuple is going to bind it to the local IP of the actual Raspberry Pi. So that's what this empty string here is, on the port that we specified in the constructor. And then got some more debugging print statements here. And then once the port is bound to the socket and IP, we're actually going to listen on that port for incoming connections. And then this constructor is actually going to pause here until client.py establishes a connection with it. So once it's established a connection, this s.accept line is going to be able to fully finish executing, and we're going to assign the connection and address variables here, and then we're going to say self.c equals c. So we're going to change or save the connection as a data member of this object. And then when the constructor finishes, we're going to say a connection established with whatever IP has connected to the Pi. And then these two functions down here, we can start with alert server. So alert server takes a message, which is going to be a string. It's going to encode it so that we can send it freely through the socket, and then it's simply going to say self.c, which is the connection we saved as a data member earlier, and that's going to use the socket function send the bytecode over. And yeah, that's pretty much it. This last function here is just a bit of cleanup. So whenever we want to close the connection, we just do self.c.close. So it's going to use the close function from the socket object c and close it off. Cool, so that's pretty much everything with our implementation.